Hello and welcome. My name is Max Biegler and I'm here as the AHSS Guidelines joining editor for WorldAutoSteel. Today I would like to talk to you about tailor welded blanking and more in depth the digitalization of tailor welded blanking by combining different numerical simulations. So tailor welded blanking is a technology where steel sheets are joined with laser welding and then formed into the final shape in order to get just the right steel grade and the right thickness in the right location. So you can lightweight a lot with tailor welded blanking by adapting the load and the strength of the material locally. Cold form tailor welded blanks especially offer a high lightweighting potential because there are now new steel grades with a lot higher strength. But these present some challenges when processing them, especially from springback and cracking. So I'm suggesting here an integrated design of the simulation chain to include welding and forming to make better tailor welded blanks with higher strengths. On the right, you see a typical tailor welded blank consisting of two sheets for a longitudinal front member. So let's look more into the detail. We want to link the welding and the forming simulation. So how do we do that? We want to, in the end, include the welding zone into the forming simulation. So we need some way to transfer the data from the welding simulation to the forming simulation. So a closed data chain between both simulation suites. We need a fine resolution of the mesh of the discretization in the weld zone so that we can really also look at the small areas for the weld metal and the heat affected zone. These are in the millimeter or sub-millimeter area, which is usually a smaller resolution than you would use for a forming simulation. And finally, we also need the material properties for the welding zone. And this presents some difficulty as these zones are so small. For instance, you cannot readily do a tensile test or other forming related tests with them. But some material data exists also for the weld metal and the heat affected zone. And often a best guess for these material properties plus some literature values already bring a great upgrade in the resolution of these simulations. On the right, we're seeing the standard way that these simulations would be set up and the process chains would be set up. So we're starting with the material, we weld, we have the forming simulation, and finally you get the product. In the bottom, we're seeing a formed S-rail geometry, so a simple test geometry, where we have different zones included in the forming. So we have the weld metal as well as the heat affected zone in the forming simulation, and we can look for cracking and thinning based on these small zones in the tailor welded blank. And so with this process chain, I can really dig deeper on the unique properties of the welding zone and optimize springback and optimize cracking further. And finally, if I have a working simulation data chain, then I can start to play with it some more. For instance, I can, if I look at it from the forward side, I would weld or do a welding simulation, push the data to the forming simulation and optimize, for instance, the positioning of the welding seam or optimize the exact, the angle and the exact sheets that I would want to use. But I could also, in the forming simulation, make some assumptions and find out which welding properties or which welding line geometries would be ideal, and then push these back over to the welding simulation and try and work out parameters to achieve these sorts of welds. So I can really go through this whole chain in the forward direction, also in the backward direction, helping me to iterate and to optimize my tailor welded blanks. And with that, I'd like to conclude my talk. I presented a quick idea for a digital simulation process chain for tailor welded blanks. With this, we can push the formability of higher strength steels, and we can use the latest steel grades also in tailor welded blanks. And we have some challenges here that are especially the required high quality material data of the weld seam and the high resolution of the weld in the forming simulation. But these are, we're capable of overcoming these with modern simulation tools. In the end, to conclude, by including the digitalization in tailor welded blanks, we can increase the lightweighting potential of steel and of the vehicle applications of the steel. So thank you very much for your attention. My name is Max Biegler. If you have any questions, please don't hesitate to get in touch, and I hope to see you next time.